3.3, using special angle pairs to determine if lines are parallel. So we're basically going to do the exact same thing we did in 3.2, only this time we're not going to know that the lines are parallel. We're going to have to determine the lines are parallel based on the special angle pairs. So we're kind of going backwards, okay? We're kind of like switching up the order that we do things. So your essential question, which pairs of angles must be congruent and which must be supplementary to conclude two lines cut by a transversal are parallel? Whereas in the previous lesson, notice I started with, when two parallel lines are cut by a transversal, which of the angle pairs are congruent and which are supplementary? Okay, so these are what we call converses of each other, and I'll explain that in a minute. So to kind of help you with this, let me just show you or ask you a question. If we knew that the measure of angle 2 and the measure of angle 6 were equal, so I know that angle 2 is congruent to angle 6, what does this tell us about lines L and M? Well, angle 2 and angle 6 are corresponding angles. And anytime I have parallel lines cut by a transversal, corresponding angles are equal in measure, or they're congruent, right? So if I know that corresponding angles are congruent, then I can conclude that the two lines that are cut by the transversal are going to be parallel. So we can conclude that they are parallel. I'll use the parallel symbol, because corresponding angles are congruent. Okay, so let's talk about what the converse really means. So if I made a statement like if P then Q. So for example, if it's raining outside, then it's wet. Okay, pretty simple example. But basically my hypothesis here is raining outside. If it's raining outside, and my conclusion is then it's wet. Well, what happens if I switch the hypothesis and conclusion? I basically get what we call the converse. So if it's wet, then it must be raining outside. Well, that's not necessarily always true. And we are skipping over like really studying this logically, because we can't cover everything. But all I need you to know right now is that if I give you a statement, something like, if it's raining outside, then it's wet, I can switch that hypothesis and conclusion, just like I did here, right? So the Q goes first and then the P goes last. And basically now I'm saying if it's wet, then it's raining outside. The reason I'm going over that is because we've already learned a bunch of theorems. So last section, 3.2, you learned a bunch of theorems, like for example, the corresponding angles theorem, which said if two parallel lines are cut by a transversal, then the pairs of corresponding angles are congruent. Well, today in this lesson, you're going to learn about the converse of that theorem. The converse of that theorem basically says, it doesn't start with the fact that you have parallel lines. Okay, it just says, well, if we have any two lines cut by a transversal, so that the corresponding angles are congruent, then the lines are parallel. Notice that that came last. Okay, so that's what we're doing today. We're basically saying, let's look at the angle pair relationship. Let's see if they're congruent or supplementary. And if they are, depending on that angle pair, like these are corresponding angles, then I know that line J and K are parallel. Okay, but I'm not starting off this lesson. I'm never going to start off with any lines that are just given to me parallel. Whereas in your last lesson, that's how it all was. Every time that you looked at the lines, right, every single one, it was given to you that they were parallel to begin with. Okay, so the new information here are the converses of the theorems, okay? So if two lines cut by a transversal so that the corresponding angles are congruent, then the lines are parallel. All right, so moving on to example 1. We're going to find the value of x that makes M parallel to N. We want these two lines to be parallel. Okay. I can do this a couple of ways. But one thing I noticed is that 72 and 4 times x plus 5, these two angles right here, they are not one of my special angle pairs that we've learned about anyways. But I can make them relatable to each other. So 72, this angle here is corresponding with this angle, right? So now I can say, well, if this is 72 degrees, right, I can make this 72 degrees as well if these two lines are going to be parallel, because corresponding angles will be congruent. And now notice, between these two angles, I have a linear pair, right? These two angles are forming a line. So then I can say that 72 plus 4 times the quantity x plus 5, those two angles together form a linear pair, so they add up to 180 degrees. Okay, so I'll go ahead and distribute. Combine like terms. Solve for x. Divide by 4. I get x equals 22. And so in order for m to be parallel to n, that's what x is going to have to equal, right? And I did that using corresponding angles, but it didn't ask me to explain that. Okay. Or really, I used the corresponding angles converse. Okay. So I just went ahead and copied a bunch of these for you guys. You've already learned about the alternate interior angles theorem. If two parallel lines are cut by a transversal, then the pairs of alternate interior angles are congruent. Well, now, what if we don't know if the two lines are parallel? So if any two lines are cut by a transversal so that the alternate interior angles are congruent, then the lines are parallel. Actually, let me use my yellow one. So if I know that alternate interior angles are congruent, then I know that the two lines that are cut by the transversal are therefore parallel. Same with alternate exterior angles theorem, right? If two parallel lines are cut by a transversal, then the pairs of alternate exterior angles are congruent. That's what we learned last time. And now we're going to do the converse. So if two lines are cut by a transversal, so that alternate exterior angles are congruent, right? I know that the alternate exterior angles are congruent. Then I can conclude that the two lines are parallel. So that's the new information. It's basically exactly the same thing though. There's not much new here. Alright, consecutive interior angles theorem we learned last time in 3.2. If two parallel lines are cut by a transversal, then the pairs of consecutive interior angles are supplementary. Okay, that's these two right here. So the converse of that would be, well, if I have two lines cut by a transversal so that the consecutive interior angles are supplementary, then I know that the lines are parallel. So if angle 3 and angle 5 are supplementary, meaning they add up to 180, then J will be parallel to K. Okay, so that's the new information. I'll highlight that. And I just copied all of this stuff out of the book for us, which is why it looks pretty bad. But at least we have it there. And you can feel free, write a repetition here. Hey, what's the alternate interior angles converse? Right? And then you can write what it is if you need to get repetitions writing it. But I think it's better to kind of use it. So let's use it. So use the diagram for the following questions. Given the information in each exercise, state the reason, the converses above, so the ones from the previous page, why lines A and M are parallel. Okay, so if I know that the measure of angle 2 is equal to the measure of angle 6, okay, now I can conclude that A is parallel to M, and the reason for that is because I have corresponding angles that are congruent. Right? So I can say this is really the corresponding angles converse. Or I'm totally fine with you just saying corresponding angles congruent. Okay, now I know instead of measure of angle 2 being the same as measure of angle 6, the measure of angle 3 is the same as measure of angle 6. So if that's true, then I know that these two lines are parallel. I got two lines cut by a transversal so that alternate interior angles are congruent. So I'll do the same thing. Alternate interior angles are congruent. Okay, now in the next one, I'm given that the measure of angle 3 plus the measure of angle 5 is equal to 180. Well, these two angles, this is a special angle pair. These are consecutive interior angles, and if they are supplementary, then I know that these two lines have to be parallel. So I'll say consecutive interior angles supplementary, or are supplementary. But if I put R in there, I'll probably run out of room, so I'll just leave it like that. And the last one, the measure of angle 1 is equal to the measure of angle 8. Well, that tells me that these two lines are parallel because alternate exterior angles are congruent. Okay, so with all of that information now, we are able to construct parallel lines. So this is a construction that you're going to need to be familiar with. All right, so we are going to use a compass and a straight edge to construct a line through point P that is parallel to line M. So in order to do this, I'm probably going to come down here, and I'm going to redraw line M and point P. Get my ruler, find my compass. Where's my compass? All right, so I'm just going to draw some random line M. Go down a little bit more. And then I'll put point P up above somewhere. Let's see, I'm going to need a little bit more space. Let's go here. Oops. Oh, spider there. All right. Now let's just look through the steps here real quick. So I'm going to draw some arcs here. I'm going to end up drawing some line through point P, but I'm going to end up drawing some arcs here. And look at what kind of arcs I'm drawing. I'm actually constructing two angles that are congruent, and those two angles are corresponding angles. So by constructing corresponding angles that are congruent, I get parallel lines. Okay, so that's why this construction is happening right now. All right, so we're going to draw a point and line. So start by drawing point P, which I already did, and line M. Choose a point Q anywhere on line M and draw QP. Okay, so I'm going to just choose a point. I'm going to do it very similar to what theirs looks like. Choose a point Q, draw a line. I think that should work. Okay, so now draw arcs. Draw an arc with center Q that crosses QP and line M. Okay, so draw a line here, and I'm going to turn my page. Okay, so I got that arc crosses QP, crosses line M. Okay, label the points A and B. Using the same compass setting, so I haven't changed the radius of this at all, draw an arc with center P and then label the point C. Okay, so I'm going to draw it so that it crosses. It should be about the same size. Okay. And where it crosses QP, I'm going to put point C. So now I'm going to copy an angle, which we've done before. We're going to draw an arc with radius AB. So this radius here is what I need. So I'm going to go from A to B. It's pretty much the same. All right, so there it is. So I'm going to draw an arc with radius AB and center A. All right, so center A means that I put the compass at A, and I draw an arc so that it goes through B. Okay. Using the same compass setting, draw an arc with center C and label the intersection D. So I'm going to come over here. I'm going to do the exact same thing. Oops. Let's try that one more time. Okay. And this intersection is point D. Now draw a parallel line. So basically draw line PD. And this is the line that's parallel to M, right? So PD, see how this angle is going to be the same as this angle, AQB. So now I can just draw my line through PD. And that line is parallel to this line. And I can show that by putting little arrows. But basically what I'm looking for are these constructions. I'm looking for all these arcs. Okay, example 3, we're going to determine whether lines are parallel. This one's a little bit complicated, but I'll walk you right through it. So in the diagram, we know that P is parallel to Q. So these two lines are parallel, and we know that. They didn't have to tell us that. We see the little arrows here. We know that angle 1 is supplementary to angle 2. So we know that the measure of angle 1 plus the measure of angle 2 is equal to 180 degrees. I'm going to leave the degree symbol out so I don't confuse it for a 0. Okay. So I have to prove that R is parallel to S. All right, so let's see what we've got here. So first of all, because lines P and Q are parallel, I know, basically I've got this transversal R. I know that angle 2 is congruent to angle 3 because of alternate interior angles. So I know that the measure of angle 3 is equal to the measure of angle 2 by alternate interior angles. And from here, I'll do a little bit of fancy math. So instead of putting angle 2 in here, I'll substitute in angle 3 because it's equal to angle 2. So now I can say that the measure of angle 1 plus the measure of angle 3 is equal to 180 degrees, right? I keep using degrees, but it's going to mess me up eventually, I'm sure. Okay, and that's by substitution. I'm just writing down my reasons over here so that way I know what I'm doing. Well, hold on a second now. If angle 1 plus angle 3, if those add up to 180, then that means that these two are supplementary. And if these two angles here are supplementary, I'm going to turn it on its side here. I'm going to ignore all the rest of this. Well, angle 3 and angle 1 are consecutive interior angles. So if they're supplementary, then the two lines that form those angles with the transversal have to be parallel, right? Okay, so that's basically our argument right there. So we know that R is parallel to S, and that's because consecutive interior angles are supplementary. So all I did here was I did a little bit of fancy math, right? I set up the fact that I was given that angle 1 and angle 2 are supplementary, so I added them up to equal 180. Then, because P and Q were parallel lines cut by a transversal, alternate interior angles are congruent, so I set those two equal to each other. I was able to substitute angle 3 in for angle 2 because they're the same. Okay, that's all I did there. And then I was able to conclude that lines R and S are parallel because, look, my consecutive interior angles are supplementary, which I showed right here.